So question 3 says we have 100 liters of 30% cranberry juice, and it's made from 20%, a mixture of 20% and 70%. And we need to figure out how much of each was used. So I can, again, look at this as a proportional problem and kind of put this on my proportional balance here. So I have 70%, I have 20%, and I'm going to need to make a mixture of 30%. And so we have a difference of 80 of sorry, not 30, but we have a difference of 50% here. That represents the difference between the two extremes. And we have a 10% difference here. And I'm just going to write that in like that. And here we have a 40% difference. So we can set this up as a proportional problem, and we can say that this is 4 parts out of 5 that is going to be the 20% because we need to move it more to the 20% side. So we need more of the 20% juice. So we're going to use 4 parts out of 5 of 20%, and we're going to use 1 part out of 5 of the 70%. Okay, so we have 100 liters, so I can work out the proportion. So for the 20%, I'm going to do 40% over the total 50%. The part-whole ratio is equal to the part that I want. I'm going to call that X. Okay, and the total is 100 liters. And using that proportion, we end up with 80 liters of the 20% juice. Okay, so if I want to figure out the 70%, well, we can just do subtraction. But we'll do this as a proportion as well. It's a 10 to 5 or 1 to 10 to 50 ratio or 1 to 5. And we'll call that Y to 100 liters. And Y works out to be 20 liters of the 70% juice. So that's one way we can do it. The other way would be, and that's fairly efficient if you understand how that works. The other way is to use to use a system of equations. So we're going to let X be the 20% juice and Y be the 70% juice. And for the amount of pure juice that we have is going to be X liters times 0.2. So 0.2X will give us the amount of pure juice that we have, and 0.7Y gives us the amount of pure juice that we have from the 70%. And we're going to come up with 2 equations here. So the first equation is going to be, we have 100 liters. 100 liters. Okay, so we're going to say that our first relationship is the amount of 70% and the amount of 20% is equal to 100 liters. Okay, so that's the volume. We need another equation for the total amount of pure juice, which we'll calculate by 30% of 100 liters. So we're going to have 30 liters of pure juice. And to get that pure juice, we're going to add those together. So the amount of pure juice from the 20% plus the amount of pure juice from the 70% is going to give us 30 liters of pure juice. So there's my 2 equations. I'm going to multiply equation 2 by, I'm going to make that equal to 1. So I'm going to go 5 times equation 2. And that's going to give us 1x plus 3.5y is going to be equal to 150 liters. Okay, so there's my equation. I now have 0 pairs here, which I can cancel out. So there's my 0 pairs. So I'm going to subtract these from each other. And I'm going to end up with y minus 0.35. 3.5 is going to be negative 2.5 y equals negative 50 liters. Okay, when I work this out, y divided by that is going to give me 20 liters of the 70% juice, and plugging it back into my equation, well, together they add up to 100 liters, so that's 80 liters of the 20% juice, which is the same solution I had using that proportional strategy.